Okay, so I'm going to go over some of the data requirements that we have for AGWA, and that all set up so that you can run AGWA successfully, and then also go over a little bit about file and data management and workspace management. So I don't know what happened. It crashed again. Let me try it one more time. All right. Is everybody seeing that?
Yes.
Okay. So basic data requirements are a digital elevation model, and we support any raster format that ArcGIS supports. So if it loads into ArcMap, we can use it. For soils, we support GNATSCO, GSurgo, Surgo, StatsGo, and FAO, and potentially more soil formats in the future if we have time to implement them. For land use and land cover, out of the box, we include lookup tables for the National Land Cover Data Set and for the North American Landscape Characterization, which is NALC. But we also support global data sets, or your own user-defined land cover data sets. All that you need is to create a lookup table that associates those land cover data sets with the hydrologic parameters. So I'll go into that a little bit more in a few more slides. The location, the area of interest, you need to pick your watershed, pick your outlet point, and then create all your data and download all of your data according to that area of interest. You need precipitation data, and then optionally you need hydrologic unit maps or hydrologic HUC watersheds in the US. Those can be used to make sure that you're grabbing, when you're going to these these websites to download your land cover data or to download your DEM. Using the hydrologic unit maps allows you to make sure that you're downloading all of the area that's contributing to that watershed, where you want to prevent having any of that data cut off because you didn't grab the full extent. Okay, so kind of the process here is locating your watershed, going and downloading your DEM. Two good sources for DEMs are the national map. That's probably your best shot for getting a DEM in the United States. And then if you're overseas or international, the USGS Earth Explorer also provides global DEMs. The resolution's quite a bit coarser, but it does have global data there. And then there's also various, I think, commercial DEMs that are available at higher resolution that you could probably get internationally. For soils, you can get the Surgo and the StatsGo from the Web Soil Survey or the USDA NRCS Geospatial Gateway. I think there's also a box link, which I should add to this presentation. The NRCS just redid a lot of their websites, so a lot of these links are, some of the data is actually hard to find right now, but usually a Google search will get you where you need to go. The GNATSCO and the GSurgo data, I do believe that's on an NRCS box website. And then the FAO data is provided at this link, and then we also have the lookup tables that are required. We provide those with AGWA for the FAO soils data. For land cover, the National Map Viewer, again, is one location to get NLCD data. You can also get it directly from the mrlc.gov website. I believe the NLCD data is now on a 3-year refresh. So they're coming out with more frequent snapshots, which is very useful for doing change analysis over time. The USGS gap data is also supported and can be downloaded at this link. And then we have future support for land fire coming. And one of the things that provides is a more direct measure of cover data instead of relying on a lookup table to give you an average cover or canopy condition. Getting into precip data, Canaris 2 takes design storm data, which you can download from the NOAA Precipitation Frequency Data Server. They give you basically a table of depths and durations and return periods for different locations within the United States. You can also use user-defined depth and duration. So if you have an observed event, then with a depth and a duration for that, you can input that directly, and it will disaggregate into a hyetograph for you. If you have the actual observed hyetograph for an observed event, then you can input that directly as well. Instead of having just the depth and duration and disaggregating it, you can put in that breakpoint data. And then finally, for Canaris 2, as Dave mentioned earlier, we support radar data. And I think the Weather Service also has an archive of historical storms that you can, I don't know if there's a link for that, but that you can get access to for running historical radar. SWAT takes daily data versus the event-based data for Canaris 2 and REM. So basically, you just need a daily total precipitation value. Those can be obtained from the NOAA National Centers for Environmental Information Climate Data Online portal. DayMet also has, I think, 1 kilometer grid cells of historical daily totals. And then you can also rely on the stochastic weather generator and SWAT if you don't have any observed data to input. So one of the important steps is projecting your data. One thing about projections is if you just have your data in geographic coordinate system, like NAD, N83 or WGS 84, those locations are given in decimal degrees, and you can't calculate areas and you can't really calculate lengths from geographic coordinate systems. So that's the primary reason that we need the data to be projected so that we can calculate areas and we can calculate dimensions and lengths. Some of the projected coordinate systems have units of feet, like state plane typically is in feet, but all the calculations in AGWA and the models are assuming that the projection you provided is in meters, which is much more common. So just be aware of that. If you're using state plane, you should probably reproject that into something that is where the units are in meters. So that's kind of your first step is getting everything projected. AGWA has warnings where if it detects an unprojected DEM, it'll give you a warning before allowing you to proceed. We think we've put those in everywhere, but there may be some tools or some sections of the tool that are not checking for that. So we've tried to program in validation to prevent you from doing something you shouldn't be doing, but we may have missed some things. So just be aware. The next thing is buffering the area of interest. I just talked about that a little bit. We can use HUC maps to ensure that your entire watershed is represented. It's kind of disappointing when you've done your delineation, your discretization, and you've done your parameterization only to see that your land cover only covered half of your watershed and you have a bunch of null data on the places that you didn't buffer out your data far enough. So that's why we ask you to to buffer your area of interest a little bit, just to make sure that we can come up with parameter values and parameter estimates for every part of the watershed and not have any model crashes. Sometimes you want to clip that data back down to reduce processing time and storage on your computer. When you download the NLCD data, oftentimes you download it for the entire US, or sometimes you download it for individual states, the same with the GSurgo data. And so that data can kind of be large and unwieldy, and that's when you want to clip your data down to the buffer that you created in the previous step. StoreGround and StatsGo soils data. In the next slide, I'll kind of show a little bit of management that needs to be performed with this data because there's two parts to it. There's a spatial data set that contains the different polygons representing the different soil classes. And then there's the tabular data that contains all the associated soil values for those different polygons. So the second step, or the two-part step for this, is that tabular data, when you download it from the NRCS, it is basically just in comma separated value text files, CSV files, and that the CSV files must be imported into the access data template that's also provided with the Surgo download. And again, I'll cover that in the next slide. One of the nice things about GSurgo is that you don't have to do that import step. Everything's provided in a file geodatabase, both the polygon soils data, also raster-based soil data, and all of the lookup tables, all the soil data is all in one database. And AGWA implicitly knows where to look for that data, since it's all self-contained. And then for FAO, it's again usable as is, because we have the tabular soil data included in the AGWA directory that is on our website, and that hopefully you've already downloaded as part of the installation instructions. So this is kind of the work, the step-by-step process of using the Surgo data. Here's the access database. Get my laser pointer on here. This is the access database that's provided with the Surgo survey. You'll see the spatial data. This is where the soil polygons are located. This tabular folder, that's where the CSV files are located. And then even though this access database here is 12 megabytes, it's actually empty. That's just containing templates and macros for importing this tabular data into this database, so that AGWA can access it in there. So to import that data, what you have to do is you need to access, double click on the file to open it. As you open it, this pop-up generally shows up first, where you have to click on stop all macros. That will disappear, and then you'll have to click on this ribbon where it says to enable content. And what you're doing here is allowing the macros that are in the database, you're giving them permission to run so that you can import all of that tabular data into this database, so you don't have to do it by hand. Once you click enable content, the next thing that pops up is the import, this import tool. And in this window is where you'll paste the tabular folder from this location. You'll just copy that path, paste it in here, and click OK. And then as it begins to import, you'll see progress bar on the bottom of the window filling up and emptying as each table in that tabular folder is imported. And then once it's complete, this soils report window pops up and you can close access, and that database is ready to be used with AGWA. One note about that database in AGWA is when you're running the parameterizations, AGWA remembers the last database that you selected, and it doesn't remember that, but it remembers the location of where you selected it from. So if you're working in two different watersheds that have two different surveys, and it's been a while since you've used AGWA and you're working through the process, and you go to select your soil survey associated with your soil polygon, it's going to pop up the last place that you selected that database from. And if you've changed locations, then this is an opportunity that happens quite frequently to make a mistake and choose the wrong database. And basically what happens is you'll complete the land cover and soils parameterization part of AGWA and find that you have 0 values for all your soils data. So that's easy enough to correct. You just have to perform the parameterization process again and select the right database. But if you did have one takeaway from this slide or from this part of the presentation is just remember that to double check the databases that you're selecting during the land cover and soils parameterization. Because if you get zeros, you've probably selected the wrong one. Once you've exited that, once the reports window is complete, you can exit access and it's ready to use. SWAT precipitation, again, it's daily data. There's a few requirements for that data to be ingested in AGWA. We need a rain gauge point theme to associate the daily data with a location. And that rain gauge point theme needs to have a gauge ID field that you can select that has basically the identifier for the tabular data, the field in the tabular data that you provide, because you can provide multiple rain gauges, and you need to have a way of correlating each point rain gauge location with the tabular data, the daily data for that particular gauge. That's done using a rain gauge ID field and the rain gauge point theme that corresponds to a field name preceded by G in the unweighted precipitation file that has the tabular data daily totals in it. So again, just to reiterate, in the unweighted precipitation file, this is a file that is a DBF or a CSV or potentially an XLS sheet that has a gauge ID in it that corresponds to the gauge ID and your rain gauge point theme. So this is typically a numeric value in your rain gauge point theme, and in the unweighted precipitation file, that numeric value would be preceded by a G, because I think DBF, one of the limitations of DBFs is the field names cannot begin with a number. So that's why we have this G prerequisite. The other two fields that you need in your unweighted precipitation file are a year field and then a day field, which contains the Julian day of the year for each year. Again, multiple years of record are recommended to capture long-term climate trends in SWAT. Typically, we need multiple years of data. The SWAT model usually takes a couple of years to stabilize, so the water balance. So, you'll typically run 2 years of data and throw that 2 years of data out and have 5 or more years of daily data. That's actually what you use in your for your reporting. And then if the daily rain gauge data has some missing days, those days can be filled in and generated stochastically if you provide a -99 value for the missing data. So here's some overview of some best practices of what we've learned from using AGWA over the years, and hopefully it can impart to you. Keep your input and your output data separate, keep it organized, name things meaningfully so that you know what they are and you can find them, and don't have to spend time figuring out what is what. If you're familiar with ArcMap and you're a power user, and you might want to set some of your default workspaces and Scratch workspaces to a specific location, just make sure if you do that they stay as file geodatabases. If they're not file geodatabases, some of the steps like the land cover and soils parameterization or the discretization may crash because AGWA is expecting that data to be stored in a file geodatabase. Doesn't really matter where that file geodatabase is, it needs to be a file geodatabase as opposed to just a regular folder. One time saver that I like, and this is really up to you, is saving my map document in the project folder that I'm working with. So The way you can practice this in the tutorials today is if you have a tutorial workspace folder for each exercise that you perform, that is the location that I would save that map document, because then it allows you to use this shortcut and the catalog view of ArcMap. Clicking on this home button will take you to the location of your map document. And if you have your output data, your delineation and your discretization and the simulations created in the same location that you're storing your map document, then clicking on this home button is just a quick shortcut to navigate to that folder. Again, just emphasizing again, using descriptive names for your data, your delineations, discretizations, and parameterizations is just really important for when you have done a project and then you have to go back and look at it in the future and try to figure out what's what. As you can see here in our tutorials, we didn't do the best job of naming some of our delineations or some of our discretizations or some of our parameterizations. So don't follow the example that we set in the tutorials by heart, because there's room for improvement there. This is just a brief snapshot of what your workspace and the generated files in AGWA would look like. Basic first step is creating delineation. That creates a personal geodatabase containing the water delineation feature class. This is created in a location that you specify with a name that you specify. So in this screenshot at the right, I've created two delineations called D1 and D2. And this MDB extension is the extension of a personal geodatabase. That's going away. You can't use personal geodatabases in ArcGIS Pro, so that will transition to a different type of database in the future. But anyway, so once you create the delineation, it creates this file geodatabase, which stores the delineation feature class in it, and then subsequent GIS data that is created as part of this delineation. For example, the discretization, and then any of the lookup tables that are created during the parameterization process, all of that gets stored and kind of organized by the delineation. So you don't create a discretization and store that somewhere else. It's kind of hierarchical in nature. So that's your stop for looking for all your data, is where things are created in that very first step. So the next step after you've done your delineation is your discretization. Dave mentioned that a little bit earlier, where we basically split the watershed up into model elements using basically polygons and polyline feature classes representing the hill slope elements and the stream model elements. Those again get stored in the delineation that you've selected to discretize. After you do that, you do your land cover and soils parameterization. That creates those lookup tables I mentioned. And those again are stored in the delineation geodatabase, and they're named based on the name that you gave the discretization. The next step would be creating your precipitation files, and those are actually stored as flat files, and they're not stored in the geodatabase. They're stored in subdirectories below the geodatabase. So again, I've created two geodatabases here, and then I've created two discretizations for those delineations. And so here's the folder that corresponds to the D1 geodatabase. We have a D1 folder. I've also created a D1S1 discretization inside this geodatabase. So you can't see it here, but that's where the GIS data would be stored for that discretization. So we write input files and we write precipitation files for a discretization. And so those input files get stored below a folder named after the discretization itself. And so here we have our preset folder, and here we have our simulations folder. And those are flat files. They're basically text files that you can view in a text editor, because that's what the model ingests, the Kinneris model and SWAT model. So that's why they're stored here in the file structure of your workspace versus being stored in the geodatabase, because the models cannot ingest the geodatabase to run. And again, so in this preset folder, for every precipitation file you write, there will be a precipitation file created in this folder. And then for every simulation that you create, using a combination of preset file and a selected parameterization, it'll create directories underneath this that contain and that are named based on the simulation that you've created. So that's the overview I had for the GIS data and kind of the organization and structure of the tool. So are there any questions? I guess that there's a chat window here. Do all input data need to be in the same projection? The recommended answer, our recommendation is yes. We found that the soils data will be reprojected on the fly in ArcMap. So if that is in geographic coordinate system, it will be projected to the same projection as what your DEM is in. When you do the parameterization process. But part of that projecting on the fly that occurs, you don't get to see the result of that. So that's why we recommend that you go ahead and make it the same projection ahead of time so that you can see what you're actually inputting and not relying on things being converted behind the scenes. And the raster data will definitely be required to be in the same projection. And this is where we'll give you a warning if the DEM is unprojected or in a different projection. So, well, I guess we give you a warning if it's not projected. And whatever projection the DEM is in, that's what we compare all the subsequent raster data to. So when you get to the parameterization step, your land cover data must be projected to the same projection as the DEM. If it's not, we'll give you a warning and we won't let you proceed. Is soil data available for only the USA or worldwide? It's both. So worldwide would be the FAO data, and you can download that. I think it's as a shape file, a layer file, and a few other formats that you can get from this link right here. And then in the US, again, that would be the Sergo Statsco or GNATSCO or GSergo, where you get that data for the US. What is the minimum number of rain gauges needed for SWAT? One. Actually, you don't even need one if you use the stochastic weather generator. But the more the better. Yeah, as Phil says, you can never get enough rain gauges. And then what is the best buffer distance to use for the study area boundary? I would say a couple 100 meters would be a good place to start. I've seen places in really flat terrain where part of the watershed, part of the Huck watersheds in the US actually didn't represent the delineation well based on the DEM, and I actually needed to go out more than a couple 100 meters because the Huck boundary actually did not capture the entire watershed. It was for some reason different, but I would say a couple 100 meters is usually safe. And then if the daily precept data has missing values, will AGWA automatically fill the missing values? AGWA does not do it itself. SWAT does. And it only does it for the records that have a negative 99 value. So if you have an omission, it needs to be set to negative 99 instead of just omitted, which would show up as a null value, or instead of being set as 0. So just make sure that it's negative 99, and that will trigger the weather generator and SWAT to fill that value in. Okay, I think I got all the questions there. Thank you, and thanks for your patience and getting the presentation going.